Okay, welcome to my tutorial on how to create multiplayer games and experiences for the Oculus Rift. We'll be using the Unity game engine and the Photon network plugin. You can see Photon here, it's made by Exit Games. You can go to exitgames.com and check that out. It's used by a lot of multiplayer and social virtual reality games, so I highly suggest you use it. So yeah, my name's Hayden Lee. I'm a developer at Converge, which is a virtual world built for the Oculus Rift. We had a lot of early users that have a lot of them are game developers themselves, and they've been asking us how we did the networking in Converge, and I promised a few of them that I'd make this tutorial and show them how we did it because it's not terribly complicated. So here it is. We went through a couple of different iterations ourselves on how to do this, so hopefully this will save some time for you. What you'll end up with is networking similar to what you can see in this video, where you can see one person, they have an avatar that's just a head, and that avatar is tracked to their Oculus Rift DK2. So as they move in the real world, they also, you can see them moving in the virtual world. Okay, so let's get right to it. So I have a fresh Unity project here. The only thing I've done is import both the Oculus Unity integration and the Photon Unity integration. I just wanted to do that to save some time. And let's get right into it. I'm going to drag in, just going to create a just a cube or a plane just for something for the avatars to sit on. Okay, now let's drag in the Oculus Player Controller. So down here in the OVR, then prefabs, you have OVR Player Controller. Let's drag this guy in. Now a lot of people's first way they try to do this system is via instantiating the OVR player controller via the network. Now, you run into some issues if you do this. One of them is that if you don't turn off the cameras for each different player as they get spawned into the world, you can run into this really disgusting situation where you have too many cameras rendering in the scene, like way too many. We actually did this in Converge. The first time we launched it, we had like every player was rendering the two Oculus cameras, so the FPS quickly dropped to like 5 FPS, which is way too low, and everyone was freaking out, and so were we. But now we do it like this, and it works well. So, dragging the OVR player controller, put it in the world, just click play to make sure it works. Just saving the scene, just to make sure we can walk around the world. Okay, cool, and as I move my Oculus Rift around, you can see now I'm moving, the cameras are moving around. Okay, so that's all cool. Okay, we're going to go straight into creating the prefab that represents the player. This is going to represent the player as far as the networking that's involved with the player and any attributes that the player has. So let's create a new script. Create a new folder called scripts, then a new C# script. Let's call it just networked player. I'm just going to sync this mono develop project so that gets the Visual Studio working. Going to delete this old camera, and I think I can just pull this up in Visual Studio now. Okay, Oculus networking toot. Okay, so here we go. Here's the script we just created. Okay, so there's a couple of things this script needs to actually, before we get into this, let's just create another script. I'm going to just have the general networked controller. This is probably this is as important. So networked or network controller, let's call that. So this guy's going to be in charge of creating the, instantiating the different players in the world. Okay, network controller. So let's just drag this guy onto, let's get an empty object and call this network controller and drag this guy onto that. So we've got the network controller here with just one script on it. Now, this is the code for the network controller. I've got it prepared. It's pretty small. Okay, so it's kind of three things here. First, as soon as the world starts, we're going to call connect, Photon network connect using settings, and that's going to connect us to the network. Then after we connect, it initially just connects you to the lobby. I'm using Photon Cloud, which does this by default. So unjoined lobby gets called. We'll see this get printed. Just some default stuff here. As soon as we join the lobby, then we're going to join the specific room. And there's this handy method, join a create room. We're going to connect to this tutorial_converge room. Now, once we've joined the specific room, then we're going to join, or we're going to instantiate the player. But let's just try and get it, make sure the network's working before that. So I'm hoping to see, it'll just say joined lobby in the console here. Okay, cool, join lobby. So that means we're now connected to the network. I just always want to test that first. Okay, so now we want to instantiate the actual player. So let's create another empty, and then we're going to drag the networked player onto it. We'll change the name to networked player. Okay, now this is something that's important. Create a folder called resources. And in that folder, drag the networked player. And then you can just delete it from the hierarchy. Okay, so that made a prefab out of the networked player. And what we want to do now is instantiate that guy. Okay, so now when that's instantiated, this script will run. Let's call I'm instantiated, something like that. Okay. Press play. We should see the join lobby. Ooh, cool. So that didn't work. I'm missing something very important. So on this networked player, we want to add a component called Photon View. Okay, and we also want to add the networked player to one of the observed components of this Photon View. Just change it to reliable. There we go. Okay, so should work now. Now console, there you go. Join lobby, and I'm instantiated. Cool. Now we want, when that player is instantiated, we want to be able to sync the position of your head in the real world with your avatar in the virtual world. So how we're going to do this is we're going to create a, let's drag the networked player back in, an instance of that prefab in here. And we're going to add a 3D object. Let's just add a cube. Just make it a bit smaller. Just changing the scale. And just move this networked player up a bit. Okay. I'm going to call that cube avatar. Okay, it's at the avatar is at 000 within the network player, which is perfect. Now, let's apply this prefab. We can just hide it for now. We can actually just delete it. Okay, so that's that. Now, this network's player is going to control a few different things that's important for the networking. Namely, the avatar. Okay, just make this public. Public game object avatar. Okay. Now we're also going to want to have references to the OVR player controller. So I'll just have these as transforms of the global object of the player and the local object. So I'll explain what they are in a second. Okay. Okay, so they're here. Let's add the avatar as the avatar. And I don't think this is going to work. Yeah, I'm not going to be able to drag that, so we're going to have to just set this up at the start. So the player global. So this is where the avatar is in space, and this is where when you move the avatar, this is where, or when you move the player, the avatar gets moved around the location. That's the global player. The player local is responsible for the head movements specifically. So when the player moves their head in the real world, the player local will be the transform for that movement, both rotation and position. So let's just do this with just the GameObject.find. So OVR player controller. And the local is going to be within this player global. So find, it's going to be OVR camera rig and then CenterEyeAnchor. There's definitely cleaner ways to do this, but so we'll be good for now. Okay, so those two are set. We actually only want to do this if you're the owning player. So you only want to do this for the player that you created, not anybody else's player. So let's create a conditional here that if photon view dot is mine, we're going to do this. That works only if we're the player. If we created this player. Okay, it's giving me red here because I forgot to add, this needs to be a photon mono behavior, so make sure you change that. I'll copy this whole script and put it in the blog post that I'm writing, so that won't be an issue if you miss some of these steps. Okay, so I think that's good. Now, in the update, we want to, actually, Photon has this concept of serialization, and I'm not sure exactly when this runs. I think you can change it, but it basically means when new data, or however often you want this to happen, it'll get new data and send it to all the other players in the same room as you. So I've just written this out already, copied it in. You've just got to get used to this syntax. The stream is writing. That's when for you sending information out, and then in the else branch, this is when you're receiving information. So when we're sending data out, we only want to be sending 2 or 4 things. We want to send the position and rotation of the global player and the position and rotation of the local player. Then when this is received on the other end, sorry, there's just an ant crawling across my screen. There we go. Okay. The position and the transform of the player is updated by the corresponding values. So because this networked player is on the parent of the avatar, we'll have the actual player, the networked player game object. That was just an empty game object with this component. That'll be moving around based on the kind of global position, and then the avatar will be moving around based on the local position. So that's all the code you need. Now, one other important thing is that if this is you, so if the photon view is mine is true, then we want to attach this avatar to the OVR player controller. Actually, specifically we want to attach it to the CenterEyeAnchor, and this is going to mean that when you move around, the networked player component is going to, or game object is going to stay at the same position as the CenterEyeAnchor, which is just going to make some things easier in the future. So how we do that is we're going to do this set parent GameObject set parent. I think it's must be transform. Yep. Set parent to the player global, or no, player local we want. That's important. Okay, so let's test this out now in Unity. Okay, so we get those messages. However, it did not, it just created the networked player outside of the camera rig and player controller, so I'll just check why that is. Oh, I forgot tracking spaces. Here we go. It's new in the latest SDK. Okay. So let's try that out. Okay, cool. So on the left here you can see in the CenterEyeAnchor the networked player is attached to there. Okay. Now this cube is like way off, so I gotta check out what's up with that. Cube is 0, 0, 0. This is not. Okay, that looks better. Okay, so I just had to change the location of the network player. I think it's because of this. Might have to reset it in the... Yeah, that's still wonky. So what I'm going to do is change, just for the sake of this tutorial, I'm just going to say this dot transform dot position, let's go local position equals vector 3, 0. Okay, so there you go. You can see the cube is under these cameras here and moving around. As I move the mouse, it's moving around. Also, because we parented it, it's also, now I'm moving my Oculus Rift and you can see the cube moving in the virtual world. Just expand this a bit quickly. I guess, yeah, there you go. So as I'm moving the Oculus Rift around, you can see me the cube moving around correspondingly. Okay, so looking forward, looking up, looking to the, or tilting my head right, tilting my head left. Cool. So that's working great. One thing that we want to do is actually hide the avatar for ourselves, because we don't want to see our own avatar unless we're in like a third person mode or something. So let's just set that avatar to false if it's within your own player controller branch. And what else do we have to do? That may be it. Okay, cool. So I'm just going to build right now. I feel like I'm missing a lot of things, but it's maybe that's just how easy it is. Okay, adding the current scene. Okay, what we're going to do is build and run this guy. Test director Rift, that's windowed mode. Okay, we'll put one over here, and then we'll start another one. Ooh, that's interesting. So there's a cube in the middle. What's that doing? Ooh, the variable player global of networked player has not been assigned. I think that's fine. Okay, so I realized that I made a mistake in how I did the syncing here. Now, what I should have done is local position, and that was causing the error, and local rotation. So that's it, and that's good. I'm also going to unhide the your own avatar so I can see it in the scene view, and we're going to build right now. Okay, so we're in here, and as I'm moving my Oculus Rift, as I move down, you can see the other cube moves down as well, and that's going over the internet. That's the different instance. You can see as I move, you can see my cube on the ground as well as I walk around. And I can go into the other app and see the same thing. Here I'm seeing the right eye. I can move around. There you go, and you can notice the cube's a bit choppy. You can do some interpolation and prediction as well to make that not as choppy and smooth like it is in Converge. But yeah, you're pretty much 90% of the way there at this point. So hopefully you could follow along with that. It's pretty easy. It's really only like what 40, 20, 60 lines of code to get that working. And it's pretty modular because you can quickly change the mesh of the avatar, so you can put in different meshes there, so your avatar can look however you want. Even if you could even go and have a full body avatar with an animation on that for the walking as well. It'd be a very similar concept. So with that, I'll leave it there, and thanks for watching. If you have any questions, shoot an email to me, hayden@converge.co, or leave them in the comments. And I shall see you in the metaverse. Catch ya.